Добрый день, уважаемые коллеги. Я надеюсь, что меня хорошо слышно. Сегодня будет вебинар, который посвящен базе данных по наноматериалам, которая сейчас входит в национальную подписку, организатором которой, да, и самое главное, плательщиком которой для всех, для нас, да, является Российский фонд фундаментальных исследований. То есть у каждого слушателя сейчас в его научной организации должен быть доступ к этой базе. Если вдруг по каким-то причинам у вас нет доступа к этой базе, не стесняйтесь по итогам вебинара написать мне письмо, да, меня зовут Дарья, я с удовольствием, да, отвечу на все вопросы, и мы будем решать, почему произошла та или иная ситуация, да, почему у вас нет доступа. Сразу скажу, что вести вебинар будет моя коллега Проноти, да, она специалист по нанотехнологиям, она отвечает за этот продукт, она отвечает за эту платформу, расскажет про все обновления, которые будут, которые планируются, которые уже сделаны в системе. И самое главное, вы не стесняйтесь, задавайте любые вопросы либо в чате, который вот тут есть, да, я буду за ними следить, вопросы можно задавать как на русском, так и на английском. Если вдруг уровня английского не хватает, я их переведу без проблем. Да, по итогам вебинара я разошлю всем слайды, которые я показывала про ноти. И мы также подготовим сертификаты о том, что вы прослушали этот вебинар. Надеюсь, что в ближайшем времени мы сможем делать такие вебинары на русском языке для того, чтобы собрать более широкую аудиторию и люди знали о том, что эта база есть возможность ей пользоваться, соответственно, чем лучше мы с вами пользуемся базой, за которой платит государство, тем больше шансов, что и в следующем году мы также будем получать ее бесплатно, а не за собственные средства. Это конец такой вводной части, да, я надеюсь, что все хорошо слышно, хорошо видно. Я сейчас передаю слово своей коллеге Проноти, да, которая специалист, опять-таки представлю ее по наноматериалам, и она уже будет говорить на английском языке. Pranoti, thank you, you can start.
Okay, wonderful. Thank you very much, Daria. And hello. Welcome to the Nano webinar. My name is Pranoti Kshirssagar. A little bit about me. I have a bachelor's degree in metallurgical and material science engineering from an Indian university. And I have a master's background in material science from a German university, University of Stuttgart. And recently I defended my PhD work also at a German university called University of Tübingen. And for the past 8 years, almost 8 years, I have been working with some kind of nanoscience and nanotechnology, with the last 6 years being dominated by the 2D materials, so the two-dimensional materials, which was graphene and boron nitride. And right now, I'm speaking to you as the product manager for the Nano database, as Daria already mentioned. And I would like to tell you all about the Nano database that is developed at Springer Nature, which is a research tool to accelerate your research output. I welcome you to the webinar. All right, let's begin. So as you probably already know, as you all are researchers, science is beautiful. That's why we do it. That's why we do the research. But there are quite a lot of difficulties in our road. The road to the success is always tough. There are a lot of pitfalls, and it doesn't help that there is more and more data. In a way, it helps that there is more and more data that is coming up. For example, at this point today, we have more than 34,000 peer-reviewed journals, which are only focusing on nano. Then we have more than 24,000 active researchers, and this family is always growing. And we have the patents which are being applied for, which are more than 8 million. And this basically means that finding the right data in this pool of, or this desert of available data is like finding a diamond in the desert. And this is where Nano offers a solution. So Nano is a research tool which is developed by researchers for the researchers. So we understand the needs of the researchers and we adapt in order to make life for scientists like you easier at all times. So as I mentioned, navigation, a quick and accurate navigation through the scientific data is one of the keys to the success. And this is what we want to address with the Nano database. So the Nano is basically nano.nature.com, and you all already have access to it. I would like to stress on that fact. As you probably already know, nanoscience and technology is a booming field. It's one of the most booming fields. However, the information and the data is scattered all over the place. And there is no standardized nomenclature for the nanomaterials. And this is the pain point we want to address with Nano. Speaking of the pain points, let's talk a bit more about the pain points that you face as a researcher in today's time. As I mentioned, I keep bringing this up at all times, the large number of irrelevant research results. What happens, I remember from my researcher time from my past life, there were a number of times where I would look for a recipe to synthesize a nanomaterial, and after going through 10 papers or 20 papers, I would pinpoint maybe 2 recipes for the nanomaterial preparation, and even then it won't work. So what does this mean? That the data is irrelevant. So there are a lot of irrelevant search results existing around us. The next thing is to validate the relevancy. How do you check if you can trust the data? And that is done by accessing the original source where it comes from, and not from the papers which are building on the original source, because during the building on process, the information can easily be lost or misunderstood. I already mentioned the scattered information is one of the big pain points of the researchers like you. So the information is scattered, which means that you have to spend double or 3 times the amount of time in finding the right information, or going through all the papers, or going through all the patents, or going through the different books, which is also quite time consuming. A single place, a one-stop shop is not available for information about nanomaterials and the nano devices with specific properties and specific applications. As you probably already know, the properties and the applications of the nanomaterials or nano devices might be similar to the other bulk materials, if I may call steel and iron or aluminum as bulk materials, if I may call them so. However, the properties and the specific applications are different and very particular for when you go to the nano size. And speaking of the 5th pain point, which is the tedious amount of work that is required to reconstruct the synthesis methods or preparation methods and the steps for the nanomaterials and nano devices from the text that you finally pinpoint to, or finally you filter down to. So basically the major pain points of nano researchers like you are the large number of irrelevant data, absence of the access to the original source, information being scattered even if you have access to the original source, and the unavailability of a single list or one place for all the nanomaterial data, and the tedious amount of work that it takes to pinpoint the right data point that you're looking for. Now, there are also other ways of coming to the information that you want. Depending on the field that you're working on, there are different research tools which are already available from other sources. For example, for biology and medicine, there is PubMed. Then there is for engineering, there is another one. Specifically for chemistry, there is another one. For physics, there is a different one. However, as you probably already know, nanomaterial sits at the center or at the intersection of all of these fields. So physics, chemistry, material science, engineering, biology, medicine, nanomaterials and nano devices find application in all the different disciplines of science. And hence, what we need when you're looking for a literature or a specific information about a nanomaterial is one place where all of this can be found. And this is what we offer with nanoscience and nanotechnology literature all in one place, which powered by the artificial intelligence. And I will get to that when we will go to the live demo of the Nano database. So basically what we do, we use machine learning to filter the nanotechnology database or nanotechnology literature. All right, then now I will go to the platform itself and give you a short walkthrough of how the platform looks like and how you can use it in your daily life. Yeah, so the Nano platform, a bit of a history, was launched back in mid of 2016. So it's about 3 years old. So it's still quite young. And as you already see, we have the Nano content can be understood in 3 different categories. So we have nanomaterial summaries. We will go into the details of all 3 of these categories. Then we have nanotechnology articles and we have nanotechnology patents. I would like to bring to your attention the URL, which is nano.nature.com. So while I'm telling you or demonstrating the platform, you can already go on your computer, or you can do it afterwards as well, right after the webinar. All right, let's look for, I don't know, for the sake of convenience, and as I mentioned, I have been working with graphene. Let's start with graphene. If I put in graphene as in the search box, what happens is that I will be prompted from all of these big numbers. Remember these big numbers, 27,000, 750,000 articles, and 23 million patents. What we see is already the information that we are looking for is filtered. So whatever, all the literature or all the data that is available and tagged with graphene is visible here or is prompted here. So we, for example, in case of patents from 23 million, we went down to less than 160,000. So that is already a huge filter that we have employed by putting in a particular search term. So a smart search for scientists is very important. Now coming to the nanomaterial summaries, what do we see? First of all, you can sort the information based on the relevancy or based on how recent the information is. Now what you see on the left, there is another way of filtering the information that you see. The results that you see on the right is on the left. There are several filters. For example, if you want to filter based on the structure of the nanomaterial, and as you probably already know, that the structure of a nanomaterial is extremely important in terms of characterization, properties, applications, biological effects, and that's why we offer this filter here. So you can filter based on the structure of the nanomaterial. You can also filter based on the specific property or properties that you're looking for. And there are quite a lot of properties. I have to scroll down quite a bit now. You can also filter based on the application, where the nanomaterial is applied or where the nanomaterial application has been reported in articles or patents. And the last but not the least filter is the source. Now this source is basically the place where the information that you see in the nanomaterial summaries is coming from. The information is coming from scientific journals and also patents. As you already see here, for example, this patent office, the US patent office, and all the other journals. I guess you already can point out which journals you follow rigorously. All right, let's go a bit deeper into the nanomaterial summaries. What happens when we click on the nanomaterial name, the name of the nanomaterial? What we see, what we are prompted to, is that the information that you will see below is coming from 5,500 articles, scientific articles, and 134 patents. Now remember, this information will always be updated And hence, probably next week or in 2 months, you will see more number of articles or more number of patents, depending on what is updated. Now we go down. For example, in case of the properties, what do we see? Let's do electrical property as the electrical conductivity. Can we do that? Let's see. All right. When I do electrical conductivity, when I look for the electrical conductivity under the properties subtab in the nanomaterial summaries, what do I see? I basically see a table where how the property is defined or the term is identified. And if the value is available in the source, you will see the value. So you don't see it here, but for example, in the case of electrical conductivity, if you drop this one down, you see that there is the value available. That is the electrical conductivity, which is reported in this paper. The original paper is always there. You can always go to the original article or original patent and go through it yourself. Now, in some cases, the value is available, so the numerical value with the unit is visible, but in the other cases, for example, the fourth result here, you see that it says details in source. So why is that? Details in source is because when there is a calculation or when there is no specific value reported in the original publication, instead of misleading the scientists, what we do is we say, okay, the details are in the source. You might want to take a look at it yourself instead of us taking out the value. Now, how does this value appear here? How do these values come out, and how does this size and the medium and all this information comes from? So we basically have full-time employed subject matter experts with either PhDs or at least master's degrees in scientific fields who are extracting this information manually. What does that mean? That means that there is a team of researchers who go through they're basically, the job is to go through the articles one by one and extract the information manually. So all the information that you see here under the nanomaterial summaries tag has been extracted manually, and that goes for the properties, the applications, the characterization, biological effects, preparation, everything. Everything that you see on the nanomaterial summaries tab has been extracted manually. So it's a huge amount of effort. Now, what you also see is that when there is the experimental paper, you will see that it says experiment in in this journal and this year. When there is a theoretical paper, which is also extremely important, it says calculation. So when it's a theoretical paper, it would say calculation. When it's an experimental paper, it would say experiment. In the case of patents, it would say, for example, claimed in XYZ patent. So you can already filter out and you can get an idea as to which literature would be relevant for you and which won't be. So this is an advanced filtering of the literature, the nanoscience and nanotechnology literature. Okay, let's go now to the preparation tab. Now, when you want to synthesize a nanomaterial, and I already addressed this pain point at the beginning of my presentation, the preparation or the recipe to synthesize a nanomaterial is a critical point or a critical step in a nanoscientist's life. What do we do here in the nanomaterial summaries category? If you go to the preparation of the nanomaterial, we are still seeing the preparation for the graphene as the nanomaterial. And for example, if we do chemical vapor deposition, this is one of the methods of preparing. Okay, I made a spelling mistake. That's why you don't see it. Let me try it again. Deposition. There you go. And now we should be prompted, and from the information or from the preparation methods which are available, what I will see is only the results that are relevant to graphene preparation following the chemical vapor deposition method. Yeah. So what do I see? Is that the information is extracted from the original paper. The source is always there. The original source very important. It's always there. If you want further details about this process, you can always go to the original source, the original article. What is the advantage on the Nano platform is that you can filter through the different methods that have been reported by the articles or the patents. And I remember from my time when I was trying to prepare the nanomaterial, or I was trying to synthesize the nanomaterial, I had to come up with my own structure. For example, I sometimes use Excel sheets, or I sometimes use Word docs or handwritten notes. On Nano, it's already extracted. The information has already been extracted and you already see it, everything. And for example, if you are using nickel as a catalyst, you can go into the details of the method one. If you don't use nickel as the catalyst, if you use copper as the catalyst, for example, in the case of method two, you're in the copper foil. So you can filter the information that is available very precisely and more effectively. That saves you the time and the effort that you put in the literature review process of your research. Now let's go back to the platform again, and let's go into the articles tab, which is the nanotechnology articles tab. Let's go for gold nanoparticles instead of graphene at this point. Remember the articles, the number of articles that are included in the Nano database or existing in the Nano database are about 750,000. And when I do gold nanoparticles as the search, what I am prompted with is 43,000 or 44 or less than 44,000 articles. So again, similar to the, as I mentioned before, a huge filter has been already put up. Now, similar to the nanomaterial summaries tab, what you see, you can filter the results that you see here based on the relevancy, most cited, or most recent, the recency of the results. What you see on the left are furthermore filters. You can filter the information that you see on the right based on the source. What do I mean by the source? I mean the publisher, for example, ACS, Wiley, Springer, Elsevier. You can filter based on that, and you can filter based on the journals and also the publication year when the paper was published. If you are looking for a particular paper, or if you until last week you already went through all the papers which are published till 2016, for example, so in that case you can always only choose 2017 and 2018 and make your life easier. Now, what I want to draw your attention to, as I had mentioned already, the artificial intelligence or the machine learning. What this does, this is where the artificial intelligence kicks in on the articles category on the Nano database. What we show here, there is the name of the article, there is the authors, the journal where the article is published and the year it is published, and the abstract is also available. Now, what is the beauty, or what is the interesting feature on the Nano platform is this part here. So the Nano article discusses this short summary, which you see, it's different for every article. Now, where does this come from? So this is where the artificial intelligence is coming into play, where the AI is basically going through the entire article and extracting the information and coming up with a summary of its own. Now, mind you, this summary goes beyond the abstract and beyond the keywords which are inserted while submitting or publishing the article. And this is very important, and this will be customized based on what is the search query. So for example, as I already mentioned, it's different for every article, and the more precise you are in your search query, the more customized and more precise would this short summary of the article be. And this already also makes it a bit easier to navigate through the humongous amount of articles which are available about Nano. And for example, In the case of the first result, it says that the gold nanoparticles were coupled with a drug and the nanorods, and there is information also about the surface and the cells. What the second article talks about is gold nanoparticles with heavy metal ion. Now, mind you, the heavy metal ion part or the transmission electron microscopy, which is a characterization technique, is not in the title. That means that the AI works. It gives us the relevant results customized to the search query. Now let's stick with the gold nanoparticles and go to the patents tab. What do we see here? So as I had mentioned, again, similar to the nanomaterial summaries and the articles, the patents from 23 million, we are down to about 32,500 patents roughly. Similar to the other two categories, so the nanomaterial summaries and the nanomaterial or nanotechnology articles, you can filter the results based on the country of assignee, the filing year, and the jurisdiction. Now, in addition to the information about the patent, such as the title, the IPC code, the jurisdiction, the filing date, what we also show on Nano, and this is very important, is the claim. So if you all, as you probably already know, in case of patents, the most important part of a patent is the claims. To evaluate a patent, what you do, for the first thing you do is you go to the claims. And usually the first claim is the most important and all the other claims are based on the first claim. So what do we have on the Nano platform is that the first 5 claims are translated and you can scroll through the first 5 claims of every patent right here. So this is available for all the patents that you see here. For example, if I read the first claim or the first 5 claims in this patent, which is about production of porous gold nanoparticles, I'm like, okay, yeah, this is okay, but not exactly what I'm looking for. You can always go to the second patent and go through the claims yourself, the first 5 claims, with the first claim being the most important. What does this give you is that this gives you it accelerates your literature review, which includes the articles and the patents, and makes your life easier. And the time you save, you can use for data analysis or spend more time in the lab, or you can just drink a coffee. That is also happening. So basically, what Nano does is gives you it's a research tool which gives you the opportunity to accelerate your research when it comes to the articles, when it comes to the patents, and when it comes to finding information about the properties, the characterization, the application, or biological effects of a nanomaterial. So remember, the Nano URL is nano.nature.com. And with this, I would be more than happy to answer your questions if you have any. Thank you very much for listening to me. Daria?
Спасибо за внимание. Если у кого-то вопросы, мы будем рады на них ответить, но вот я вижу, что на данный момент вопросов никаких нету. Если возникнут вопросы, не стесняйтесь написать напрямую Проноте. Pronote, can you please share your email address on the screen?
Yeah, I can do that. Let me just go to the presentation and I will write it here. Sorry, I didn't write that before.
Just in case there are some questions, so they can pass to me or directly to you.
Yes.
Сейчас на экране email Проноте, да, если у кого-то будут вопросы, и кто-то не хочет меня вовлекать в процесс решения, да, ответа на этот вопрос, не стесняйтесь, пишите напрямую Проноте. Если же у вас вопрос будет на русском, напишите его мне, и я с удовольствием переведу и отправлю, соответственно, вопрос Проноте, вас в копию, для того, чтобы вы получили ответ именно от специалиста, который занимается нано, да, наноматериалами, вообще базой по наноматериалам. Если же вопросов нету больше, спасибо большое за внимание. Thank you very much, Pranoti, for your time, for sharing this to everyone.
My pleasure.
Да, соответственно, сегодня до конца дня я разошлю всем участникам слайды, которые показывала Pranoti, и в ближайшее время подготовим сертификаты и вышлем их. Спасибо большое за внимание, хорошего всем дня. Thank you very much, Pranoti. So this is the end. I mentioned that we will share the slides by the end of the day today, and we will prepare the certificates and also send them out.
Yeah, that sounds good. Thank you very much, Daria, and thank you everyone for tuning in. And have a nice day.
Thank you. Bye-bye.
Bye.